Virtual network-based tunneling, or VNBT, is part of Aruba's dynamic segmentation solution. VNBT basically provides switch-to-switch VXLAN tunnels. Wouldn't it be great if all your ports facing your devices or users had the same configuration? There's no need to set specific configuration for each port. Well, that's what colorless ports gives you. And that can be used together with VNBT, but it's not mandatory. So with colorless ports, either local or downloadable user roles can be used. So local is LUR and downloadable is DUR. So what happens is the user or device will authenticate at the switch via either 802.1x or MAC authentication, and either the radius server, which can use LUR, or ClearPass, which can support LUR and DUR, will send back either the user role name or user role content. So in this example, I have a user that's authenticated at this switch, and he's assigned to the VLAN 10. Once he's assigned, he can be placed into the VXLAN tunnel and can be sent towards the egress VXLAN device. So that user or device is placed automatically into the VLAN that's mapped to the VXLAN tunnel. Here's the demo topology that I have. This is a campus network with multiple buildings with 6300s and 8325SX switches that connect to non-Aruba access switches. To get the benefit of colorless ports, the devices should be connected directly to the Aruba switches. I also have an on-premise edge data center in the campus, and I have A325s which are functioning as the centralized layer 3 default gateways for the different subnets. The VXLAN tunnels are created between the VTAPs at the different buildings and to the data center. And with this setup, I have full network connectivity between the different subnets. It's all routable. I also have a device that's connected here that we will use to check. So the first demo I'm going to show you is the colorless ports on the 6300. This is the topology seen in NetEdit, and let's look at the configs on the 6300. The colorless ports are here. Ports 1, ports 2 are examples. They all have the same configuration. So as you can imagine, all 48 ports facing clients or users could have the same exact configuration. There's no need to specify the desired VLANs. Once the device or user is authenticated, they will be placed into the correct VLAN. From a connectivity perspective, I'm using a traffic generator that has IPs on different subnets. As you can see, I have connectivity within the same subnet on different VTAPs, and there's zero traffic loss. Transmit and receive is the same. I also have connectivity across different subnets, the 101 and the 102 subnet, or the 101 to the 103 subnet. This is the IP that we are interested later on. And right now, yes, you can see there's no traffic loss, there's full connectivity because we have not applied the ACL. From ClearPass perspective, let's look at the MAC address that we're interested in. We can see it's been assigned to VLAN 102 as part of the current policy. From the A325 in the data center, we can see this MAC address that we're interested in is on VLAN 102. It's using VXLAN EVPN and has a next hop of 1.4, which is the correct VTAP we're expecting it from. Let's proceed to change the policy and apply ACL to this device. So from ClearPass, we have a policy that basically matches this MAC address, and we have two actions. Right now, profile action does not have ACL attached. We're going to move the profile of the ACL up so it will be used for this MAC address. After re-authenticating the client, if we look at ClearPass, you can see the new policy assigned to this MAC address is still assigned into VLAN 102, but it has an additional ACL that basically blocks it from reaching the 101 subnet. From the traffic generator, you can see that now there is traffic loss. The transmit and the receive doesn't match anymore because of the ACL in place.